Professional recording sessions with analog tape require that the tape machine be aligned for every session, matching the level, EQ, and bias level to the particular brand and formulation of tape being used for the session. This ensures the best possible performance and consistent sound quality, especially for projects where recording is done at multiple studios, with the tape being moved between them for the various sessions. The basic alignment process is not too difficult, though it can be a bit time-consuming for multitrack tapes, since adjustments have to be made for every channel. Additional mechanical alignments and adjustments may also need to be made, though not necessarily for every session. Tape alignment is done by playing and recording test tones and adjusting level and EQ controls at least 3 frequencies, typically 1 kHz for overall level adjustment, 10 kHz for high-frequency adjustment and bias level setting, and 100 Hz for low-frequency adjustment. The frequencies may vary slightly, but the basic procedure is the same. The alignment process requires the use of a calibration tape, which is used as a reference for the initial playback adjustments. These are available from MRL, Magnetic Reference Labs. Alignment tapes are available at all tape widths, but the tones always take up the full width of the tape, which allows the tape to be used for any track format that may utilize that tape width. The tones on these alignment tapes are matched to different tape speeds, EQ standards, and the specific flux level desired. To explain that last bit, tape machines can be calibrated to record at different maximum levels of flux, depending on the formulation of the tape and how much flux it can handle cleanly. Newer formulations allow hotter levels to be recorded before saturation occurs, and this provides better dynamic range and signal-to-noise ratio, printing the audio further above the noise floor. A standard flux level that corresponds to a maximum average recording level of 0 VU was established as 185 nanowebers per meter of magnetic flux on tape. To record at that flux level, playback level of the 1K tone on 185 nanoweber alignment tape would be set to 0 VU. However, when improvements in tape formulations allowed for hotter recording levels, it became common for engineers to align the machines to operate at higher flux levels, effectively lowering the noise floor. To accomplish this with a traditional 185 nanoweber alignment tape, playback level of the tones on the alignment tape could be set to, say, -3 VU instead of 0. This would be referred to as a +3 operating level, referenced to the 185 nanoweber standard, recording audio 3 dB hotter at an actual flux level of 250 nanowebers. With a 250 nanoweber alignment tape, the same flux level on tape would be achieved by setting playback level to 0. As tape formulations improved further, several operating levels were established, again referenced to the original 185 nanoweber standard. +3, which corresponds to 250 nanowebers, +6, corresponding to 370 nanowebers, and +9, equivalent to 520 nanowebers. The level you'd align to depends on the desired operating level and the level of the tones on the alignment tape. This chart shows the various alignment settings for different tapes and operating levels. Ideally, the alignment tape would have tones at the desired operating level. Before beginning the alignment procedure, the tape machine should be cleaned and demagnetized. Using isopropyl alcohol, the heads, capstan, rollers, and guides should be carefully cleaned to remove any stray gunk from the tape oxides left on them during normal operation. Since residual magnetism may build up on the heads and metal guides, these parts should also be demagnetized using a handheld demagnetizer. This must be done carefully. First, the tape machine and demagnetizer should both be off. The demagnetizer should never be switched on or off in close proximity to the tape machine, as this could accidentally permanently magnetize the heads. The demagnetizer should be at least 3 or 4 feet away when it's switched on. You'd then slowly bring the demagnetizer towards the machine, position it by each head and guide, and slowly move it up and down, then slowly pull back, and repeat this procedure for each part to be demagnetized. When you're done, again, slowly move the demagnetizer back to the safe distance before shutting it off. One additional caveat. The strong magnetic field emitted by the demagnetizer could affect the magnetic signals stored on recorded tapes, partially erasing them, so it's important to keep the tape several feet away from the demagnetizer when it's being used. In fact, recorded tapes should likewise be kept away from any device that emits stray magnetism, including power amps, power supplies, and speaker magnets, so no stashing a tape on top of a speaker unless you're willing to risk partial signal loss. Once the alignment tape is chosen and the machine is cleaned and demagnetized, then you're ready to begin the alignment procedure itself. I'll pick up there in the next video.